Hello and welcome to the next section of Unit 10. So this is actually going to take the place of 10.5, not 10.4. Alright, so this section is going to be talking a lot about x-intercepts. So we've talked about y-intercepts a little bit, but now we're going to talk about x-intercepts. So we don't usually call them x-intercepts in quadratic equations. We usually call them roots. So if you ever hear me say, or if anybody says roots, that means the x-intercepts. So in example 1, if I wanted to find the roots of x squared minus 4 equals 0, so we're trying to figure out where x, or what x could equal to make this equation true. So if I wanted to graph this, instead of putting 0 here, I could just say y equals x squared minus 4. So we start these graphs by finding the vertex. This is in standard form because there's no parentheses. So I do the x equals negative b divided by 2a. But I do not see an x in here. I have x squared, but no x. So that means b is going to be 0. It doesn't really matter what a is, even though a is 1. 0 divided by anything is just 0. So x is going to be 0. So if x is 0, then y would be negative 4. 1, 2, 3, 4. So I go down 4. So now to graph this, I can use that little pattern, 1, 3, 5, 7, blah, 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 blah. Since a is 1, I multiply each of these by 1, so they all stay the same. So my first rate of change is going to be 1. So that means I go up 1, right 1. Up 1, left 1. Next is going to be 3. So I go up 3, 1, 2, 3, and right 1. Do the same to the left side to make it symmetrical. Then next is 5. So up 5, 1, 2, 3, 4, 5, right 1. Same to the left side. So we get a parabola that looks like this. So now it's easy to see where the two x-intercepts are, or the two roots. So the two roots are at x equals 2 and x equals negative 2. So we would have two answers. That means I could either plug in 2 to x or negative 2, and the statement would be true. Because if I do 2 squared minus 4, 2 squared is 4, and then 4 minus 4 is 0, so yes, that works. If I did negative 2 squared minus 4 equals 0, negative 2 squared is also positive 4, and 4 minus 4 does equal 0. So those numbers would both work. The next one, so if I subtract 1 on both sides to get one side equal to 0, I'll have x squared minus 1 equals 0. And then if I wanted to graph it, I could say y is equal to x squared minus 1. So again, our vertex, since there's no b value, this just tells me how far to shift it up or down. So I'll start at the origin, I'll go down 1. And a is 1, so I'm just going to use the pattern of 1, 3, 5, 7, 9, dot, 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 dot. So my first rate of change will be 1, so I go up 1, right 1. Do the same to the left. Then I do 3, so up 3, right 1, same to the left, and then 5, so 1, 2, 3, 4, 5, right 1, same to the left side. So here's our little U shape, our parabola. So even though I didn't draw it very well, we can see our two y-intercepts, our two x-intercepts, our two roots, are x equals 1 and negative 1. So it doesn't matter what order you write these in, or if you wanted to do x equals 1 and x equals negative 1, you could do it like that. It doesn't really matter as long as I can tell what you're saying there. So if I plugged in 1 squared does equal 1, so yes, that's true. But if I also plugged in negative 1 squared would also equal positive 1. So that's how we get the two answers. So moving on to example 2. So if it says solve each equation by graphing. So the first thing I would do is I would divide, since I notice both these numbers are divisible by 3, I divide both sides by 3. So I get x squared equals, 27 divided by 3 is 9. And then if I subtracted 9 on both sides, I have x squared minus 9 equals 0. So if I wanted to graph it, I could say y equals x squared minus 9. So that means I'm going to move down 9. And I use the pattern 1, 3, 5, 7, dot, 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 dot. A is 1, so I'm going to use these same numbers. So 1, I go up 1, right 1. Same to the left, so I'm kind of just guessing where the x values are. Next is 3, so I go up 3, 1, 2, 3, and right 1. Same to the left side. And then 5, so 1, 2, 3, 4, 5. Right 1. I think I went a little too far to right. And so on. I should have made the x values though, because 1, 2, 3, 1, 2, 3. We will need those. All right, so the two roots. So notice there's two x-intercepts, so there's two roots. Are x equals 3 and x equals negative 3. So those are our two answers. And then the next example, well, we could divide both sides by 2, or divide everything by 2. So I get x squared plus 4 equals 0. So if I wanted to graph this, I could say y is equal to x squared plus 4. Some lines here. So there's no b value, so this just tells me to shift up from the origin, up 4. 1, 2, 3, 4. And then I'll use the pattern. Oops. 1, 3, 5, 7, dot, dot, dot. And multiply all those times the a, but a is 1, so they all stay the same. So my first rate of change is going to be 1. So I go up 1, right 1. Do the same to the left. Then 3, so up 3, right 1. Up 3, left 1. I don't really have room to keep going, so that'll be good enough. So where are the x-intercepts on this graph? Well, there are no x-intercepts, so that means there's no roots. So no real solutions. So the reason we write no real solutions is because there's such thing as imaginary numbers, which we're going to talk about next unit. So that's why I write no real solutions, because they're actually imaginary solutions. All right, so moving on to the next page. So instead of solving these by graphing, another way to solve them, which I prefer because I'd rather do algebra than graphing, but maybe you're not, maybe you don't feel the same way as me, but another way to solve these is by doing some algebra. So notice that 6 squared is equal to 36. We've kind of talked about this a little bit already, but also negative 6 squared is also equal to positive 36. So if I take the square root of 36, it could equal 6, or it could equal negative 6. So when I take the square root of 36, another way to write this answer will be plus or minus 6, because it could be positive 6 or it could be negative 6. So if I'm solving these algebraically instead of by graphing, first thing we got to do is get x squared by itself. So we got to solve for x squared. Then we take the square root, should say square root, of both sides. So this one already has x squared by itself, so the next step is to take the square root of both sides. So the square root of x squared is just x. Square root of 64, it's either 8 or negative 8. So I'm going to say plus or minus 8. So that's my answer. So it could be positive 8, could be negative 8, we don't know. because I could plug either of those numbers into x and it would equal 64. So example 4. So again, we got to get x squared by itself. So that means I can't have this 2 here. So since I'm multiplying x squared times 2, the opposite of that would be dividing by 2. So I'll be left with x squared is equal to 25. So now that I have x squared alone, I can take the square root of both sides. So x squared turns into x. The square root of 25 is 5, but it also could be negative 5. So my answer will be plus or minus 5. And then next example. So first thing I'm going to do is I'm going to add 32 to both sides. So I have 2x squared is equal to 32. So my goal is to get the x squared alone. So the reason I added 32 to both sides is because that starts the process of getting the x squared by itself. So I still have a 2 there. I don't want that. So the opposite of multiply times 2 is divide by 2. So x squared will equal 16. So now that x squared is alone, I can take the square root of both sides. It's just supposed to be an arrow, nothing else. So x is going to equal either positive or negative 4, plus or minus 4. Then finally, example 6. So first thing I'm going to do is subtract 9 on both sides. So 4x squared is equal to negative 9. Divide by 4. So x squared equals negative 9 over 4. So now that I have x squared by itself, I can take the square root of both sides. So then I'll get x equals this, whoops, that's not a good square root symbol, the square root of negative 9 over 4. But so far anyway, we cannot take the square root of a negative number. So that means there are no real solutions. So notice that I said not yet, we can't do that, so maybe that's a preview for the future. So what this would look like if I had graphed it. So let's say this is the y-axis, x-axis. If I had graphed this, since there are no real solutions, it would look something like this. No real solutions when I'm trying to find the roots means that there are no x-intercepts. So this plus 9 moves the graph up 9 because there's no b value. So it will never touch the x-axis. So that's why we get no real solutions, and that is it for the notes.